Okay, welcome to the last lecture probably of system level programming. Today we are going to work with some code that we want to first write in one C program and then later on move this out into a shared library. And we will go through that step by step, and I will start with a very simple program. So let's see what this program does. We again start with our main function. I will call this slp8.c and write the main function here. This main function, it could take an argument, but we don't really care about that for now. So we don't provide this an argument and we just return 0. And we will also include some standard IO header, and we will include standard definition header so that we can use certain functions. So we will now write a program that prints the log2 result for different numbers. Let's start. We will use the log2 function for that. We'll get to that in a second. So log2 of some number equals some other number I, and then log2 of this number I, and let's initialize this number for now to 1, and let's see whether this already works. So we compile this, gcc minus probably we have slp7 somewhere still. Yeah, I want to compile it similar as in the last lecture. So g++ minus g static slp8 pthread. Okay, this looks good. So we compile this. We don't need pthread actually because we won't be creating threads. Static, we also don't really care about that. Let's just compile it like this. Oh, this doesn't even work. Let's check out the man page for log2. Log2 says, we need to link with -lm, and it says include the math header. Let's do that. So we include the math header. And I also have a typo in there. Okay. So let's compile this again. I will compile this now with GCC. Okay. It doesn't like the format that we return here, but we still want to keep it an integer. So we will just cast this to size t, which is an unsigned size, unsigned int or unsigned long would also work, but I want to cast it to a size t in this example. Okay. Still, it doesn't know the function. And why does it not know the function? Because we have to link this function with -lm. Otherwise, we can take a look at that. Let's use LDD on slp8. This program doesn't even exist. It was not able to compile this. Interesting. Let's maybe try this with let's try this with the LM flag. We will try this first. So let's compile this, and now we see, okay, this appears to work for one number. Let's run this for a bunch of numbers. So we will maybe write a for loop, size t. We start here, maybe up to 256, and I times 2. So we will print this for every power of 2. Let's compile this, and this appears to work. Okay, great. So this is already a good start. And what we do next is we want to write our own log2 function. So let's do that. How does a log2 function work? Well, we will write a log2 function which just works for powers of 2. So it's a very boring log2 function, or actually it will work for non-powers of 2 but it will always return an integer. So it will not be very precise. Okay, so how does it work? Well, we start with the basic case, and the basic case is that log2 will return 0 for the lowest allowed value. We don't, so this program won't work for any value that is less than 1. So maybe let's do this as a sanity check here. If x is smaller than 1, exit -1. This definitely does not work. Otherwise, we compute the result, and that means that x is at least 1. Now, if x is larger than 1, we have to do something. We have to change the result, and in the end, we will return the result. So for the case with 1, this already works. So let's think about what we have to do here. So for every step, every power of 2 step, we have to increase the result by 1, and we have to shift the number by 1 bit to the right. Okay, now we shifted this to the right, we incremented the result, so this should compute a log2. Okay. Now let's try to compile this. Let's see what happens. Oh, lots of errors just by adding a function. This is a bit weird. Conflicting types for log2. Okay, this is not good. This is definitely not what we wanted. So maybe let's remove the math header because we don't need it for now. Okay, better. That removed one of the warnings, but here it still says conflicting types for built-in function log2. Maybe we also shouldn't link -lm. Okay, that didn't solve anything. And this is the point again where we want to ask the man page. Let's ask the man page, man GCC, and I see that this is a bit cut off at the bottom. Let me just, yeah, this is now mentioned also in the chat. Let me move this a bit up. Now it should be better. Yeah, now you can see it properly. Man GCC. And we had this problem. Let's think again about this problem. It said built-in function, a conflicting type for built-in function. Let's search for built-in. Oh, it is f no built-in. This is interesting. No built-in sounds very good already. F no built-in. Don't recognize built-in functions that do not begin with __ built-in _ as prefix. Okay, so this is maybe what we want. We want to pass -f no built-in here. Ah, this is good. This is good. But now it says implicit declaration of function exit. This is unfortunate. Let's check out what exit does. This is the wrong exit page again. You see, this is the manual page, not for the function, but for the exit utility. So we want the programmer's manual, so manual number 3, and here we have it. So include standard lib, void exit, int status. So we should include, of course, for exit, include standard lib h. We will do that, compile it, and let's see whether it works. Oh yeah, looks like it works. Okay, so let's go for the next step, because we want to write a library on our own. And what is the first step when writing a library? What is the first thing that we do? We now have a C file which contains everything. And the next step is we start with the header file. We start with the header file. We need header files for libraries. You see them up here. And we will include this header file. We will just call this log2h, log2a.h. So we will have multiple header versions and we will slowly make some progress. And the first header version that we write, log2a.h, will not contain a lot of things. This definitely not. It will include an include guard. And there are two types how you can define an include guard. And the one is an if and def, and then I define and end if. So you can say log2a, log2a, and here make a comment that this belongs to log2a. If it's not defined, then you would execute this code, you would run through this code. Otherwise, you would skip this entire code. This is an include guard. There's also a different way how to define an include guard with less code, and that's, I prefer this one actually, pragma once. This file will only be touched once, so it won't be executed multiple times. This is already a good start, and what do we want to have in this header? We want to start with a function declaration. So let's see, let's declare this function here. Okay, very good. We now have our function declaration. Does this already work? Let's see. We included this. GCC works without an error. What happens if we remove this function here? What happens if we comment this out? Let's see what happens. We should still see the function, right? Oh no, undefined reference to log2. Let's see whether the header changes anything about this. Undefined reference, implicit declaration of function. So the header still provides a declaration. Interesting. Okay. Let's maybe go to the next step. And for this, I will change my header. So this header in the next step will also include the implementation, getting us one step closer to the actual scenario where we have a full library, a real library. Okay, now we have this log2 function in the header file, and let's see what happens now. GCC, we compile it, we run it, it works. Very good. So this is our header file now containing the entire implementation. This is not really surprising, because what include does is it copies the entire content from this header file into this location in the code and executes it while compiling. So that means we are not actually much closer to a real library. Maybe we need a second C file. Let's create a second C file. I will create that log2c.c. Yeah, we should copy the code over from here. So we copy this code, we copy this here. Oh. Okay, now we have the code here, and this is our second C file. In this C file, we of course need the standard libh because we use exit here. Okay. Still works, but also we still have our header file, which looks like this. I will now change this again and remove the implementation, just have the declaration here, and I will store this as log2c.h. Okay. And in this one, I will also include this second header file now. Let's compile this. Doesn't work, undefined reference. What we need to do now is we need to also provide the log2c.c to the compiler, because otherwise the compiler cannot find the implementation. If we do this, it works. Let me just execute this. So I compile it, I execute it, and it works. This still is just building a single binary, right? We are only very slowly making progress, getting closer to our full implementation of a shared library, of a library and then a shared library. Okay, what is the next step? The next step would be to maybe go here into the header file again. I want to show you one more example, log2c.h, and I want to work now with a variable instead. So I will do some really ugly implementation here. And the implementation would be that we have a variable which is log2 result. And we call this function before, and log2, this is a very ugly code design, will store the result in the global variable log2 result. This is so ugly that a comment would be very appropriate if you would implement it like this. Because it's really not clear from the code that this actually modifies this variable, which we don't even see here. How does this work? Well, we will introduce this global variable here, and it's size t log2 result. This is initialized to 0 by default, okay. And we don't need a return value anymore here. And here we don't do this. Instead, we will set log2 result to result. This is a very, as said, very ugly interface design, but we want to see what happens if we try it. Log2 result is undefined. Okay, this is interesting, because this is only defined in the other C file, right? Okay, what can we do? We want to have a forward declaration, and this forward declaration should be in the header, because the user program does not know anything about it, about what this definition would look like. So we define the global variable here, and I want to have a forward declaration. Let's see what happens if I try it like this. This worked for the function. Let's see whether it also works for a global variable. Doesn't work. Now we have two definitions of this log2 result variable. There's a keyword now in C that we can use to forward declare a variable. And you might know this keyword already. Let's see whether someone mentions it in the chat. Extern, exactly. Extern is the keyword to use here. And now it works perfectly. Okay, extern is the keyword for forward declarations. Very nice. Maybe we want to change another thing. I have maybe a problem that I want to define another function. Let's say this function is called, or let me think about it. Yeah, maybe I want to declare a variable here, int log2 result as well. Or maybe let me wait a second. Let's change this. We have this size t result variable here. Let's make this a global variable as well. Doesn't sound like a good idea, but I want to run into some problems here. So let's try this. It still works. It will still work. The only change I made was making this result variable also a global variable. So SLP. And now the programmer might also want to use a result variable here, and maybe I also want to make a global variable here, int result, or maybe size t result. That's not an uncommon name, result. And we will say result equals log2 result, and we will pass this to the printf. Looks a bit more complicated, but in the end I just introduced the global variable here as well. Let's compile this and see what happens. Oh, now we have a problem, because in this other C file that we say is a library, we now have a conflict with our variable. This is not very nice. So what we should do here is, we can use another keyword here, not extern, but there's a keyword to restrict variables to their own scope, to the current scope, and that is static. No matter where you are, in which context you are, if you're in a function, if you're in a class, if you're in a C file, static will always restrict this variable to the current scope. It will always make it a global variable which is only reachable from the current scope. Let me repeat that again. Static makes any variable a global variable that is only reachable from the current scope, which also means that the properties of static and global variables are identical in a sense of memory allocation, in a sense of how they are initialized, etc. They behave the same. So static size t makes a global variable which can only be reached from the current scope. So not anymore from this other C file. Let's see whether this works. Yes, this works. Now our variable from the library does not interfere with the variable in our C program anymore. Very nice, but the code looks really ugly now. But it's fine. Let's go for the next step. So we want to go for the next step, and this would be to basically make this a real library, because for now we are still linking just the C file. So we want to make this a real library, and for that we have to go for the next step. Okay. Before we do that, maybe one more thing here, because you might wonder about this extern keyword. Can we also add it to a function? Yes, we can. We can add it here to the function. I see there's a question in the chat. You can always ask questions in the chat or via the Menti. Just use the code that I show up here. Just use the code and you can ask questions there as well. You can also ask questions in the chat. There's a question, what do you think of the new M1 chip of Apple? I think that's a bit far from this lecture, so I might go into this question at the end of the lecture if we still have time for it. But otherwise, I would first focus on the contents. The cat lies asleep over there, so she doesn't look like she wants to join the stream right now. But let me go to the Q&A. I think there are some questions in the Q&A already. Can I see that? It shows me that there would be questions, but I can't see them. Now I can see them. Show Q&A. When will we get a 3 points? After all the discussion rounds. There's a question in YouTube. What if used in the context of classes? Static vars will then be used from anywhere, or does static have multiple meanings? Even within classes, you still change the meaning of the variable. Before, it is a member variable, which is initialized whenever the object is created and the object constructor initializes it. And what you do here is you change this. Now this static member variable is not initialized anymore when the object is created, but it exists across all objects. It's the same across all objects. It's a static variable. It becomes a global variable that is reachable only from this context, that is by scoping to this object. But it's still a global variable then. Sorry for the general question, but I'm kind of lost. Can you please explain how we have to start at A4 or how, or how would you start? Thanks in advance. So for A4, this was already covered in the last 2 lectures where we use mmap and shm open, and this would be the way you start. You create those memory mappings and you let the processes interact via these memory mappings. So this is how I would start A4. I know I won't form a team in operating systems. Can you recommend some microarchitecture text tutorial? We have lectures for that, but they are in the masters, and I think they are a very good introduction to microarchitectural attacks. But I'm not aware of any tutorial that would generally introduce you to this topic, because there are quite a lot of things that you need to learn to be able to mount different microarchitectural attacks. Muss man für OS bereits SLP absolviert haben oder kann man die LV theoretisch auch ohne SLP absolvieren? So the question is whether for operating systems you need to have system level programming finished, or whether you could also participate in operating systems without having participated in SLP or without having SLP finished. It's possible technically to participate in OS without having done SLP before. It's usually not recommended because in operating systems all the contents, especially A3, will be very relevant. But also A2, very relevant. It's not necessarily a good idea to try operating systems before being done with SLP. Why do you exit on X smaller than 1? The loop simply shouldn't be run. Let me check. If X is smaller than 1. This is actually the only case where this happens. If you pass 0 and log2 of 0 is undefined as far. Wait a second. At least it's not. Log2 of 0 should be. No, log2 of 0 is. At least not a value that I can reasonably express with my function here. It's not completely correct, but good enough, I think, and better than dragging exit with you. I would say it's not defined. I see that many implementations choose to return 0 or choose to return other values, maybe in error code. I think this is not a good idea, because your software might rely on sort of correct behavior of the function, and if you want to, so if you pass a value in there that doesn't make any sense, you might want to notice that very quickly. So calling exit might be a good idea for debugging. Is it true that we have to redo the whole SLP course with all assignments if we fail the exam? Yeah, but we don't know the specifics of this yet. So in general, this is correct, but there are, or in the past, we sometimes had second chance exams if necessary. In other cases, a few years ago, we didn't even have an exam. This only was changed with SLP being changed into a Vorlesungsübung, so lecture and exercise combined. And we don't know exactly how we will handle this semester, as it is tricky right now to have an exam, and it's also not really plausible to have an oral exam online with this many participants. So we will figure out a way how we can do this without without running into resource problems and without running into situations that could be unfair to anyone. The usage of global variables to store results already seems like working with registers. Yeah, this is internally working with registers. Yeah. So the static variable is not visible outside the library C file. Yes, that is correct. Even if I would try to declare it with extern, I would not be able to access it. It's not accessible outside of this library C file. Unfortunately, the discussion was very unfair, as you were always interrupted as soon as you started talking. Could not explain anything without being interrupted. I did not get a tick because of that. So I have attended several discussions, and I have seen that especially in the beginning when there are these very, very easy questions, a lot of people want to get the points. And there we are also more careful and don't immediately give out points. So this is, of course, a challenge. But later on, there are more tricky questions. And I've seen in multiple design discussions, not design discussions, in multiple discussion rounds A3, I've seen cases where the tutor asked multiple questions, and it took quite a lot of time until someone was able to answer them. So I don't agree that it was not possible to get a tick because one was always interrupted, because I saw in each of these discussions that I've attended that there were points where no one was answering the question that was asked. And if you prepare for all the questions, then you can also provide answers there. So of course this is tricky, but I don't agree that this is leading to a situation where one cannot get a tick because of that. Of course, if you only prepare for a part, that's a risk you take. That's the same as only preparing for some questions for an exam. And if you then get the wrong questions for the exam, then you might not be able to answer them. That's how things work. Your lecture is extremely good. Maybe we can skip these questions as they are mostly about general stuff you already told us 10 weeks ago. I still find it important to answer questions if questions occur, so I definitely want to take the time to do that. Could you please explain how you can destroy semaphores and other locks correctly when used with multiple processes? One thing that you can do is you can, because you want to have one or not necessarily one process, but you don't want to have multiple processes destroying them. So the point where you would destroy a semaphore or any other lock would be when all other threads that could use this semaphore or lock have already terminated. In a situation where you have only a single process and multiple threads, destroying semaphores and locks is actually, upon a process exit, is not always necessary. Most operating systems don't have a problem with that if you do not destroy them at the end. Same as with free. There might be some archaic ones or very odd designs, operating system designs, that require destroying semaphores and locks before the process terminates. And otherwise they would have, for instance, resource leakage in the kernel. But in general, if you work on a modern operating system and you don't share these across processes, then you won't have a problem. If you share them across processes, things might be a bit different because the operating system might handle these different. The best practice then in all these cases is to wait until you have only one thread remaining. For instance, you could introduce a semaphore or some other form of counter that counts how many threads are still alive that could do the cleanup. And if you are the last one, then you do the cleanup. So the last thread does the cleanup. When will we get information on the exam? The exam, if there is an exam, it will look exactly like the exam from the previous semester. So if you find an exam like that online, I'm not sure we have it on our website, but it shouldn't be a problem to get an exam from the previous semesters. I think they are in the Prüfungsbeispielsammlung, and also if they are not, we are happy to share example exams. So you can check out what they looked like in the previous semester, and they will look exactly the same. As a follow-up to a previous last question, will the slides of the discussion rounds be available online? I'm not sure. So the tutors decided to show some slides there, and this was mainly to help them explaining why certain answers were correct or wrong, and this is more information that I want than what I want to cover in this course. So a lot of this information is not, or none of the slides that were presented there are relevant for the exam. None of these slides is relevant for the exam. The the answers and the explanations still might be explanations that were provided might still be relevant for the exam. But in general, the exam will focus on things that you have done during the exercises. So it won't contain any questions with respect to the slides that were presented in the discussion rounds. The discussion rounds will take place on Discord. Yes, they already do. How can the tutors recognize us? There's a message in the SLP channel explaining that you have to add your group number to your name, and then they will recognize who you are. So you provide your group number in the name, and then they know who you are. It would nonetheless be great to have the slides. Yes, but you would have to ask the tutor there, because I don't even have these slides. Just ask them on Discord. I couldn't find an old exam on the PBS. Can you find a way to share one example exam? Yeah, if we find time for it, we can even go through an example exam today. And no, the cat, I can't get it into the stream because the cat is sleeping and I think she wants to continue sleeping. Is this the last lecture of this semester? I think so, because we covered all of the content that I wanted to cover in the SLP lectures. Let me go back to the code. We will just quickly continue, and now we want to build something that is closer to a real library, and we will use the flag C for that. Let's check out what the man page says about the flag C. Okay, you can, for example, the C option says not to run the linker. Interesting, not to run the linker. What does that mean? Okay, let's search for -C and then a space. Here, compile or assemble the source files, but do not link. Okay, this is interesting. This creates an object file. Okay, let's try to create an object file. We will do that. Create an object file, and we want to create an object file for this log2c.c. Let's create this. What do we have here? log2c.o. Okay, let's see. Read elf -a on log2. Yes. Okay. Let's see. What do we have here? We have here a regular C binary, and you can see that the functions are even in there. log2, log2 result, the variable is also in there. They all have addresses already. Okay, this one, yes, the other one's not. Interesting. So in the object file, some of these things are already present. So it is already some form of binary. And now what we can do is, instead of the C file, we can provide the object file here. And we can link this. Okay, let's see what this does. Does it still work? It still works. Okay, this is still not a library. We are only adding more and more steps on compiling a binary, but it's still a single binary that we compile here. Okay, let's go for the next step. We will now create our first library, and we will do that with the AR command. The AR command is used to create archives, and these archives are meant for binary archives mainly. You will know these .a files, binary utility, most often used as libraries holding commonly needed subroutine, creates an index to the symbols defined in relocatable object modules. Okay, this sounds really good. So which flags do we need? Let's see, what do we have here? Oh, this is a long man page. So we want to create such an archive. Okay. Create. There. There it is. C, create the archive. Okay. What else do we want to have? Write an object file index into the archive. Maybe this is important as well, because we want to have a library. Okay. Let's see. What do we have here? Oh, this is a long man page. So we want to create such an archive. Okay. What else do we want to have? Write an object file index into the archive. Maybe this is important as well, because we want to have a library. Okay. Let's see. What do we have here? Oh, this is a long man page. So we want to have a library. What else do we have? We want to also provide AR. Maybe this also. Insert the file's member and so on into archive. This operation differs from queue. Okay, I don't know what queue means. By default, new members are added at the end of the file. Okay, very good. Let's try this. So we will use AR with the files added to this archive. We want to create one, and we want to create an index. And we will call this file log2a, and the input file is our object file. This worked. Let's see what readelf says about this. log2.a. Okay, it's still a binary thing that readelf can read. So this still works. Interesting. What happens if we compile a program with that? Let's see. So we want to compile this. Oh, wait, there's a typo here. Okay, this works. But the next step to compile a real library, I mean, we want to have this like -lm. This was the mass library, -pthread for the pthread library. We want to link a real library with -l lib. Search the library named library when linking. Okay, let's try this. So we will try to link this library with log2. Cannot find log2. That's not so good. So the question is, what do we have to do? Well, we know that these libraries have to be called differently. So this log2.a has to be called liblog2.a. Let's try whether it works now. Still doesn't work. And there's a second reason for this, why this doesn't work. Let's search for -l. I already know the solution here. Link. A lot of options. Long time to search through this. Here, L. This is important. Add directory dir to the list of directories to be searched for -l. Okay, so we want to provide the current directory here. Oh, and this works. This works. Now okay, let's try whether this actually made the change. Let's remove this library. What happens if we remove it? Then it still cannot find it. And if we create it again, and we will create this liblog. Let's first call it like this and see what happens. Still can't find it. Use -l. Oh, interesting. Or rename to liblog2a. Okay, so it even tells us if the a file is not correctly named. log2.a, we'll name it into liblog2a. Compile it. And let's see whether it still works. SAP8. Okay, let's see what this looks like. Okay, so this is the dynamic linkage information, and this doesn't have any information here about this library file. Let's also check this out with readelf. We want to know whether this is now part of the binary, so this would be static linkage, or whether it's shared linkage. And this pretty much looks like static linkage. And you can see that log2 result actually has an address within this binary, so it is linked into the binary statically. Okay, now we created a static library. Maybe we want to go one step further and we want to create a shared library. For that, we need to go one step further and create the so-called SO file on Linux. Let's check out the man page of GCC again, how to create a shared object. Let's search for shared. -shared. This looks good. Let's search for -shared. -shared. Okay. -shared. No results. Let's search for -shared again. Shared. No. Here, this is it. Produce a shared object which can then be linked with other objects to form an executable. Not all systems support this option. For predictable results, you must also specify the same set of options used for compilation. Okay, let's do that. Let's pick one of these options here and let's compile this new log2 SO file. Okay, I want to run GCC with just the log2.c, f no built-in, and now we said we want to run shared, and we also want to provide this f minus position independent code. Okay, let's try whether this works. We compiled this. This is now an object file. We will now in the next step. Oh, wait a second. This is already a shared object file, isn't it? So we should name this actually liblog2.so. Okay. Okay, let's try whether this works. I will remove the liblog2a now that we had from the previous example, so that we can be sure that it actually links this shared library. And it works. Let's see what it does. It also runs. So we were able to build a shared library as well. We might have to, like as they said, for best portability or compatibility, we should do this. And yeah, it still works. So this would be creating shared libraries. This is now separate files that are independent, and you can link them together. You can even link them at runtime with DLOpen, but this is something that we don't do in this lecture, but you might want to do that in some future lecture or in your industry job or later career. Let's go again for a few questions in Menti before we go for the last example for today. Since this is the last lecture, I would like to thank you for your hard work to make these videos very interesting. Thank you. This was by far the best online lecture this year. Thank you. This is very nice to hear. We did not even discuss break or S-break, which we would need for malloc. How is this the last lecture? Yeah, break and S-break. This is intentional because you already have worked with linked lists, data structures like linked lists in C, in ESP, in programming, structured introduction to structured programming, and this is exactly what you have to do for malloc. So for malloc, for the malloc assignment, the focus is more on implementing this yourself, because this will bring you the most understanding for malloc. Break and S-break, we can take a short look at that today if you like, but there's not much to see there. The main part for malloc, the difficult part for malloc to understand is the linked list. Are there any slides available online for SLP? Yes, there are slides available online, but for most of the lectures, I just worked in this terminal here, so you wouldn't have any slides. Where do you specify the name of the library when using it as a dependency in the main program? So when I specified the -llog2 here, I specified what library it should use. If I provide llog3, then it won't find any library. So it only finds this if I provide the correct library name. So let's go for the next one. What is an object file? What is it used for? An object file is used or can be used as an intermediate file that you later on combine with maybe with other object files together into an executable file. So it would contain compiled functions, assembled functions, compiled functions, and already some space for global variables that are initialized. So it would have a data segment, for instance, already. It would have a text section, a data section, maybe a read-only data section as well. So it is pretty much like a binary, but you would combine it with other object files to the final binary that you then execute. It would be much better to remove the exam and make 2 further exercises. We will elaborate the options there. So we are supposed to take the linked list approach for malloc. Are there other possibilities like the buddy algorithm too? Okay too, or would that be too complex? Everything is so I'm not sure whether the tutors for testing constrained anything there. So this year we implement malloc in C++, and you would have flexibility on how to implement it, but linked list is probably the one approach that takes the least time to implement. I don't see a problem with implementing something more complex, but I think linked list would be the fastest one, and it's definitely the one that the test cases are optimized for, because they have to focus on mainly one implementation. Sorry, my question wasn't posted. What means I would get 0 points and lose everything else I had because I couldn't answer questions at the end because everybody was shouting to get the tick. So I have participated in multiple of these discussion rounds, and in these discussion rounds I have experienced multiple questions where no one provided an answer within plenty of time, where you could have jumped in. If you prepared for all questions, then this should be doable. Of course, if you only prepare for those questions that everyone else also found easy, then it's also difficult. And for those questions, we also don't immediately give you the tick on having contributed a lot. So you would have had to answer for multiple questions anyway. So the challenge here is always to prepare for a sufficient amount of questions so that you can answer all the questions that tutors might raise. Yes, that is correct. No, this is the reason for this is that this is more about the discussion round and not so much about the questionnaire. So it's not, you're not losing points, you're not gaining points. Do we have to create a file to save the shared variables in A4? You're not creating a file actually, you're creating a shared memory object. This does not take any space on the disk. Instead, this will just create a path. So you have a path, you have basically a string that you can refer to access this shared memory, and multiple programs can use this path to find the same shared memory region. But this doesn't create a file, but you have to create shared memory objects. Yes, this is part of the assignment. Would it be possible to give more resources for theoretical research on the topics covered in the assignments? I would definitely recommend reading the POSIX standard or the man pages carefully, because they describe the behavior of these functions in a lot of detail. Each sentence in the man pages and in the POSIX standard is usually packed with information. So reading this very carefully will give you a better understanding. More theoretical resources. Of course, we will also work with these functions more in the next semester when you implement many of these functions in the operating systems lecture. For now, we just want to understand how they work from a user perspective. But if you want to understand how they internally work, then I would defer that to next semester. For A5, it says detect memory corruption errors. Bring in your own ideas which errors to detect, at least buffer overruns, memory corruption. Can you give us a hint in regards to solving that? What happens upon a buffer overrun? You would have malloced an array with 16 bytes and someone writes 17 bytes. Something is now overwritten that should not be overwritten. Could you maybe detect this somehow by placing something before or after the buffer that, where you would detect that it has been overwritten, although it shouldn't have been overwritten? If you find a solution for that, then you have a solution for this problem. Is there any relevant difference between naming it liblog2 or using -l log2a? I think the former one is more portable, because if you want to distribute your library, people would want to use it with -l log2, but of course you could also use the second variant if you don't want to distribute it in that way. Daniel, what determined you to make your lectures in which you test code and use no slides? Yeah, good question. Actually, I had slides in the beginning, but the problem there is that on the slides, things are often a bit detached from the actual editor. My impression is that if I really show how this works on the terminal, it gets much closer to what you need basically to try out these things yourself, because you see how these things are done in the terminal, and you see how to use these system level C features. Thank you. I will go through the questions a bit faster, because otherwise we don't have time for all the things that we still want to do. What are the differences, advantages between static, dynamic, and shared linkage? Static linkage is usually fast. Dynamic or shared linkage would have the advantage of being able to replace a library without recompiling the binary, or being able to work with being able to work also, but that also works with static linkage in some cases, to work with only a binary where you don't have the source code. So this should work for all of these variants. But for dynamic and shared linkage, one big advantage is that you can compile a new version of the shared library, use a different version of the shared library, and still use the same binary without recompiling. So you create some independence here, and it's always good to have this independence. You will also see that with synchronization. One method to get rid of synchronization problems is to split things apart and let one thread deal with this part, or one class of threads deal with this part of the problem, and the other class of threads deals with another problem. And by dividing the problem, you will make it easier to solve. Why would we have to implement heap chunk overflow protection even if ptmalloc in its current version does not do that? Maybe because you want to be better than ptmalloc. Yeah. Okay. Just a quick thank you for providing good interactive lectures for this distance learning semester. Thank you. I think it's really important to do to somehow adapt to this digital format. I think we all are not very happy with this format, and making the best out of it is probably what everyone should do. I have problems with debugging. Maybe you have a hint to start. A hint like make a hello world file when you use the program for the programming language for the first time. I would try to single step through a simple program. Take a simple program, set a breakpoint to the main function, and then just step through every line of the program and see how this works, and then try functions like print. You can use print to print the values of variables, but generally most of the things that you want to do with debugging is setting breakpoints, and at these breakpoints printing some values. This is probably the most commonly used features. Linked lists is the hardest data structure. I think there are data structures that are more complicated, but of course they will require some care while implementing, and a lot of care when testing them. Do we have to write a lot of code for A4, or is it about as much as for the other assignments? It is about as much as for the other assignments, and in the assignments overview you can see also the lines of code that the Musterlösung, the tutor solution, has. So you can see how many lines of code they added. Do you have multiple Control V's? No, I don't. Okay, let's continue. So just a brief jump over to a different topic, because you asked for this. So I want to also comply with your request here. And this request will be taking a look at break and sbreak. Man break. Here's break, sbreak. Let's copy them. We will create a function slp8b.c. Okay, we copy them here, and we will create. Okay. So these are the functions that I want to use, and I will create a main function int main. And the main function will do nothing more but maybe fill an array with the numbers from size from 0 to 16 plus I. It's a for loop. And we will fill an array at location I with this value I. And then we will write a second loop where we print these numbers. Printf array I. Okay. And now we will use we will need some memory for this array, and we could either use a local array here, size t array 16. Let's try whether this works. It's always good to try whether something works. slpb. We don't need all these flags here, so let's omit them. Yeah. Implicit declaration. Sure. Include standard io.h. Okay, this works. Let's run this slp8b. It prints the numbers. Perfect. So we have our array here. And now we could also use malloc 16. We have to be a bit careful here. Pointer arithmetic. So array 16 was multiplied. The 16 was multiplied by size of size t implicitly. Now we have to do this explicitly. So I will put size t here. And I will also explicitly, because this now has to be a pointer, cast this to a size t pointer. Writing code explicit in an explicit way is always a good idea. Okay, implicit function declaration. Yes, let's check again. Yeah, it already tells me which header to include. Very convenient. Standard lib.h. Okay, compile this, and now it still works. This is with malloc. And now we want to use break. Let's try break. Okay, break works a bit differently. Let's try sbreak first. Let's try sbreak first, and we, oh yeah, maybe do it like this. Sbreak. So my assumption here, how sbreak works, because it says increment here, is that it works pretty much the same as malloc, with the difference that it doesn't provide me with parts that can be separately allocated and freed, but it will just increase the heap all the time. Let's check out whether this is correct. sbreak changed the location of the program break, which defines the end of the process's data segment. So yes, it increases the heap. Sbreak increments the data space by increment bytes. Calling sbreak with an increment of 0 can be used to find the current location of the program break. What is the return value? On success, break returns 0. On return, sbreak returns the previous program break. This is great because that means that the pointer that it returns is the pointer that we can directly write to. Because for instance, the break is currently here. This is the end of the heap currently. Now we call sbreak with 16 new elements. Now the break is here, but it returns this value, and we can write into the memory from here to here. So this is how sbreak works. On an error, -1 is returned. Also very inconvenient because we can't check for the null pointer, then we have to check for -1. We don't do that. We don't care for the error checking in this case. But of course you should if you implement something like malloc. We just want to try whether this works, just to show you that sbreak can be used as well. Perfect. And now we want to do the same with break. Break works a bit differently because this is a bit tricky because this will be set to the new break. So we will have to take more steps here. Let's print the address of _end. That is the address of the current break. I can also show that to you. Man break. They said something in here about the end of the processes data segment. Let's see where they say this. Here, see also end in man page number 3. Man page 3 end. Extern end, eText, eData, and extern end. Perfect. Let's use this one. Extern end. Why doesn't it have any variable type here? This is implicitly an integer then if we do that like this. Address of end. Okay, let's print this. And I will return 0 here. Return 0 here. I forgot that earlier. Compile this. Too many arguments for format. Yes, this is of course wrong. We need to also print the pointer. Okay, equals %p for pointer. Undo small p for pointer. Okay. Let's run this. I don't care about the warnings for now. Okay, it prints me some address, and this address changes all the time. Okay, sounds good. Let's call sbreak in the middle. Let's see what happens if we do this. So now the break should be increased. You can see that, oh no, address of end stays the same. Interesting. So end always stays the same, although it's increased. That's really inconvenient. So we have to start in a different way. We probably have to do something like this. Void pointer end of heap equals sbreak 0. We don't work with end now. End of heap. Let's print end of heap here. End of heap. End of heap. So we can use the end symbol to find where the heap ends. But of course, if we use sbreak, we change this, but the address of this variable where in the binary it says there's the end of the data segment, this won't change. So let's run this again. Okay, still we don't see it. Oh, of course we don't see a difference because we didn't update this variable. So now I do something that we shouldn't do. Calling sbreak many times is not so nice. We should try avoiding this. So if you implement malloc, you don't want to call sbreak 0 very often. You want to basically call it one time and from then on not anymore. But now I will, for debugging, use it multiple times and you will see, okay, now it increased by exactly the amount that we expected. 16 times size t. Let's try the same now with a different setup. So we will use sbreak 0 now to obtain the current location of the end of the heap. So this is where our region starts. And now we will use break to increase this. So we will say we say array plus 16 times size of size t. It's a bit more work to type this, but in the end it will do the same thing. So we get the current location of the heap, we increase the heap, and we just for debugging print it again to see how much the heap increased. It increased exactly as before, and we can also run the code then, and it works. So all of these variants are possible to allocate memory on the heap, and with malloc break or sbreak, and you can use them in this assignment 5. But now I want to go for one more example. Let's call this 8C. This is the third example for today, and we will again need some standard io.h. We will again need some standard definition.h. We need some include standard lib.h, maybe. And we will have a main function, turn 0. And what we want to do is we want to maybe use an inline assembly an instruction via inline assembly and print its value, the value that we obtain there. And for this we will start with a variable. Let's write a simple program which multiplies something. And for that I will use the imul instruction. So let's check out how this instruction works. So let me just share another window with you for that. This one. Should be able to see this now. I will instead hide the code. You can see that yeah, this is the man page of imul, and you can see that it takes, for instance, a register and an immediate value. This is from the Intel manual. You can just search for instructions in the Intel manual or on Google, and it performs a sign multiplication of 2 operands. So what we do is we multiply a register with an immediate. We can also multiply register with register or register with memory, also possible. So what can we see in this? We can see how this works. edx eax equals eax rm double word. So eax times the register or memory double word. Okay. That means that we will multiply two values. Now, using this instruction, we know that there are 2 operands now, and we will move back to the Mentimeter and the terminal. Okay, and yeah, this time looks good. We will be able to finish this example in time. Let's call them A and B. A is 3 and B is 4. And we will printf A here. A. And we will also printf B. Now we want to multiply this, and for this we use this assembly statement. And assembly statements, inline assembly, and then takes the instructions, the code, the assembly code, here between these, parentheses here, and then, yeah, in the quotation marks. The instruction that we wanted to use is imul, and we said it can take 2 arguments. So we will just pass 2 arguments here, argument 0 and argument 1. We can just number them. Inline assembly now has 3 areas back here that are separated with colons. The first is outputs, and comes inputs, and then we have clobbers. We don't need clobbers for now. We will just provide inputs and outputs, and in our case we can just use an input and an output, and we will use constraints for that. How does that work? You have to specify a constraint. Constraint goes here, and a variable or a number or immediate value, anything that you can provide within parentheses again. Constraint is here. The constraint that I want to use here is I want to put this in a register. So I will place R here. And with plus, I can say this is both not just output, but it's also input. I can also specify which register to use. You know, the register is RAX, BX, RBX, RCX, RDX, and so on. I want to use the register RBX here. So I will write a B here, or RCX maybe, C, also fine. Let's see what happens if we run this code. Or if we compile this code. It compiles, and now I want to see what this code looks like. SLP8C less. Let's go to the main function. The main function is here. Let me just make this a bit smaller so that we can fit it on one screen better. Yeah, this works. We can see here that we have our IMUL instruction with RCX, RCX. Okay, interesting. And then it moves RCX into RAX, RAX into a local variable. Okay, so we should be able, this should already work. We should be able to printf the result now, and the result should be in A, because A is the input and the output. Let's run this program, I would say. Let's run this program and let's see what happens. SLP8C. 3 times 4 equals 9. Okay, and with this we are at the end of the... No, wait. Oh yeah, of course. This is taking... We didn't provide a second argument here. So we want to provide a second argument, and a second argument is just read only. We don't need to read from it. So the second argument, let's place it in register B. And we will put the variable b here as well. So this is, not to be confused, this is the constraint saying we put this in register rbx. And this variable is called b. Maybe I should use different names. Let's show you how this works. Let's call this number 1 and number 2. And this would be number 1, number 2, number 2, number 1, and let's see what changes. A here, this was the variable name, number 1, number 2, number 1, number 1. Now all A, B, C are just referring to the registers here. C is the RCX register, B is the RBX register. Let's compile this again and take a look again at the compiled binary. So we again search for the main function, and we again search for the IMUL instruction because this is not used otherwise in this small program. And here we can see what happened. We provided our arguments, right? This is the local variables. We move local variables into the registers RDX and RAX. RAX and RDX are then, as part of our inline assembly statement, moved into RCX as specified. This was the first variable, and RBX, the second variable, as specified. Now what happens next? We multiply RCX with RBX, and then the result is then in RCX, and RCX is copied into the RAX register. From there onto the stack again. This is dereference of the stack base pointer, and this is the offset minus 20 hexadecimal on the stack pointer, the base pointer in this case. So this moves it into a local variable, and then later on we call printf again. So let's see what happens if we execute this. Never forget to compile this and then execute it. Now, number 1, 2, 3. Okay, this still looks a bit weird. Did we not understand how this works? Well, the result should be in RCX, I would say. Let's try it in a different way. Plus b. Let's see whether the number of this one changes. Maybe I messed something up. Ah, yeah, okay. So the result, this is the error that we made here. If we take a look at this inline assembly, the result is in RBX. RBX contains the result, not RCX. Very good, very good. The question is, what happens with really, really large numbers? Let's maybe print both number 1 and number 2. I want to print both. And I want to use really large numbers. Let's say we use 1024, 1024, 1024. So this is 2 to the 30, 2 to the 40, 2 to the 50. 2 to the 50, and I want to multiply this by 2. Let's see what happens. And I removed this line. Let's add this again. So this would now be quite a large number, right? Let's see what happens. Oh, interesting, interesting. So this stays at the same value, and this is twice the value. Okay, so this appears to work as expected. What if we take a really, really large value? Is it still working properly then? Compile it. Oh, now it's 0. Maybe this number is too large, and maybe we have to then figure out what this actually, how IMUL works with overflows, but I suspect that we just don't have any bits set in the number anymore, and that's why we shifted it out. Anyway, this showed you a bit of interaction between C and assembly. So this should be a start for the last assignment. And with that, we get to the questions and answers again for the last time for today. Let's clear this. And let's show the Q&A again. How do you know if the, can we see it? Ah, yeah, we can see it. How do you know if the register you specify is not needed for something else before the inline assembly? If you specify this via such input-output constraints, let me move this down here, then the compiler understands that you will be using registers C and B here. So the compiler will make sure that it backs up whatever is in this register before. So the compiler takes care of that. If you use an inline assembly statement where this does not become clear from the inputs and outputs, then you can use the clobber list and additionally specify this register will be clobbered, please back it up. This is how you tell this to the compiler. Okay. Thank you. Thanks for the good feedback. I will see whether the cat wants to join the stream at the end. Do you like Java? I learned very much about Java when I had to implement in the compiler construction lecture at TU Graz. This was, I really liked the lecture, where we had to do something which is not very nice and not very beautiful. We had to compile C code to Java. So we had to write a compiler that compiles C code to Java. I learned so much about Java there, and it's not pretty. How about switching everything to Python in SLP? You can't write system level code in Python, that won't work. So that's not how we can do this. Do you really also do calculus classes in your study? No, I don't. No, I don't. Why do you always use size t? Because size t is my favorite type. It's exactly the size of a register, so it feels like the most natural type. Integer is a bit weird because it's 32 bits on 32-bit systems, but it's 32 bits on 64-bit systems, and set in the largest possible array that the system could possibly support. Any problems with the stream? No, Oh, okay, so there was some interruption in the stream. Okay, sorry about that. You might have to click live again to go back to the live timing if you want. For me, it just showed that I was a bit delayed. I hope nothing was lost. So the last things that I said was size t is just the most natural because it's the register size in almost all cases. Why don't we implement break instead of malloc actually? Because sbreak seems pretty predefined already. Break and sbreak are implemented by the operating system. You will do this, but not in this lecture. You will do this in the operating systems lecture. You can then reuse your malloc implementation to work with your own break and sbreak implementation actually and get bonus points for that. Is it possible that we will have to push code on GitLab during the discussion rounds? Compiling or writing code or accessing commands from the terminal should be enough. No, during the discussion rounds you shouldn't have to push code on GitLab. You can push code to GitLab at any point in time, but it shouldn't be necessary to push code to GitLab during the discussion rounds. In the man page, it says, define the end of the process's data segment. Why do you call it end of the heap then? Yeah, I simplified this a bit here. It's not actually the same, but it is in some cases, in the more simple cases, it's the same. In the more complex cases, it's not the same. So I would generally, when speaking about break and sbreak, prefer speaking about the end of the heap because that's more tolerant to implementations that, for instance, leave a gap between the end of the regular data segment and the actual heap. So the man page is a bit more restrictive there on how the behavior, what the behavior of sbreak and break should be. So I would prefer a more tolerant definition there, but I don't make the man pages or the standards. So when I create my data structure for malloc, where will these positions of memory regions be stored on the heap as well? Oh yeah, you need to find a trick how to store the data and the data structures. For instance, if you have a linked list and the user wants you to allocate 16 bytes, you will need a struct for these 16 bytes to manage whether they are in use, whether they are not in use, to be able to find them, for instance, in a linked list. And you will have to place this struct somewhere. So you might need more than just the 16 bytes that the user requested. The register RIP is the register, it's the, oh no, the RIP. So you are of course right. RIP is the instruction pointer, but as far as I understand it, R doesn't stand for register here. The naming started off with the 16-bit registers AX, and there was a lower and an upper half, which was the 8-bit halves of the AX register was then AL and AH for higher and lower half. And then at some point 32-bit came up, and then they said, well, we need a new name for the registers now because now they are 32 bits. Let's call them extended AX register, EAX. And then at some point, yeah, probably they were like, yeah, this will last forever. And then at some point they figured out that, oh no, we need 64 bits. And what do we do now? EAX? No, that's not a good name. Screw it, let's call it RAX. Who cares, right? So they messed up the naming maybe a bit there. Do we have, or maybe it's really extended AX register. Do we have time for thoughts on Apple's ARM CPU? I think this is a very interesting CPU that we definitely want to look at. Apple has been producing ARM CPUs for a while. Apple has a lot of experience there, and Apple has been producing top-notch ARM processors in the past. If you look at the iPhone processors, they are extremely powerful. They have all the state-of-the-art technology. one thing that I found really surprising at the time when Meltdown Inspector came out, that Apple came forward with a statement that said that the iPhone processors are susceptible to meltdown. This is an optimization that is pretty advanced. Intel had this. ARM had this in one of their own designs in the hope this is not wrong. I think it was the A75. I would have to look that up to be absolutely sure, but I think it was the A75. And Apple had this in multiple iPhone processors. So they had optimizations that the basic ARM reference designs didn't have. And this is something that you will find across the ARM ecosystem, that the ARM CPUs that are produced by Samsung Exynos chips, for instance, the chips produced by Qualcomm, the chips produced by Apple, they will have optimizations that the basic design doesn't have, and that in some cases are also more advanced and more, I wouldn't say more risky with respect to security, but let's say less conservative with respect to security performance trade-offs. So more on a side where they say we don't think that it is exploitable, but it's a very good optimization, so we want to have it, and not we know that this cannot be exploited, and want to have this optimization. So the new Apple ARM CPU, I'm sure that this will deliver very good performance, and will be a very good competition for the other vendors that produce top-notch performance CPUs. So ASM works with just the CPU. As inline assembly, yeah, it's still, I would say it's still a high-level language because it abstracts the actual CPU still far away. Actually, if you think about a current x86 processor, the language that you type here, so things like imul, this is an instruction for the x86 instruction set, but this is not the instruction set that your processor natively understands. So all of these instructions will be again translated on the fly into further instructions, further operations that are then actually executed. You might have heard the word microcode. Many instructions are microcoded, and even those that are not microcoded, the instructions will be translated into one or more operations that perform all the things that are to be done here. For instance, for the multiplication or for a memory operation, you might have a move into an internal intermediate register, move from this internal intermediate register somewhere else, maybe a renaming operation, maybe an operation to first resolve the address. If you store data, for instance, you first have to resolve the address, then you have to store the data, and then you also have to provide an address to this store. So this will be multiple operations that this single store instruction, the move instruction, will translate to. What's the best resource on inline assembly for C? The man pages? Yeah, good question. There's actually by the GCC as well. There's a website. If you search for GCC inline assembly constraints, you will find a very good page where all the constraints are explained. This one is a resource that I use often when writing inline assembly to look up which constraints I actually need. Can GCC be set to use AT&T syntax instead of Intel? This is not Intel syntax, is it? I don't think this is Intel syntax. It's the same as the GNU assembly. Intel syntax would look a bit different, I think. Is there a rule of thumb of when you have to use ASM other than performance? Sometimes you want to use operations that are not available in C directly, and then you want to write a small function which wraps this inline assembly instruction into some inline assembly and provides this as a C function to the rest of the program. So this would be one use case. But other than that, for performance, I think today it's very difficult to outperform a compiler in most cases. What do you say about Apple's new chip? Already mentioned, already said before. What do you think about ARM processors? Very, very nice, very good design. They don't have the backpack of backwards compatibility of the same size as x86, so this is definitely an advantage. Yeah, they deliver very good performance today, so they are definitely very well at competing. Do you like the IntelliJ setup, especially CLine and CMake? I personally, I'm using the terminal very often when compiling. So I usually don't compile within an IDE. Even if I use an IDE, I usually compile on the terminal because that feels more natural to me. But this is personal preference. I didn't use an IDE for a long time, but also I must say that these days my job has become more of a manager of a research group where the PhD students do the research and do the actual work, do all the coding, all the experiments, and I'm more more in an advising role. So I don't find much time to do experiments anymore. And yeah, teaching of course, but yeah, it's basically managing and teaching, so I don't get to develop very often anymore. I moved to Visual Studio Code a while ago on some of my computers and tried it, and it works nicely. So yeah, but it's probably a good idea to try out a few IDEs and select the one that you like the most. Are you into game development? I always dreamt of developing my own computer games, and while I was in school, I also played around a bit with these. There were these RPG game creating tools where you could basically just click together and script together some RPG games. I found that very interesting, but I never really got into game development. But I heard that Johanna Pirker does a really, really good job there. So you should definitely also check out her lectures. I will skip this one. Do you know the golden circle for presentations? The only way to improve your lecture is that sometimes it's hard to follow when you program. Maybe to know the motivation helps to follow. I think it's often a struggle to fit everything into the time that we have, and that's definitely something that I can improve in SLP. And yeah, if you take shortcuts, then of course it will be harder to follow the explanations. So basically me taking the shortcuts. So do you think x86 will get obsolete within the next 10 years in consumer electronics due to ARM? No, I don't think so. I really like x86 actually. The instruction set, I feel very familiar with the instruction set. That's why I like it, and I hope that we don't just lose x86. There are many things that we learned from x86, and I think the language in itself is not necessarily a problem. Are you familiar with WebAssembly? Only very vaguely, but several of my PhD students have been looking at WebAssembly. If you have any questions, feel free to reach out to them because they might know more about that. Or they might also have interesting bachelor thesis topics that you can start at any point if you want to work with WebAssembly. Normally we get 2 weeks for an assignment. Is there a chance that assignment 6 time schedule, which provides 1 week work at the moment, will be changed? I will check that out, but we hadn't planned that. So we planned the lecture so that we can finish it within this semester, within this year. So The only thing that we still need to figure out is how we organize the exams. So I'm not planning to move A6 to a later date, because otherwise we wouldn't be able to finish things within this year, as far as I remember. For which reason do you prefer GCC over CLang? For operating system development, until very recently, CLang was not usable at all. By now it is, but still many of the features that you need for operating system development are not supported by CLang. So it will just take some more time until they support all the things that we need for operating system development. That's why I use GCC. How much is your netto income per month as a professor or researcher? I'm not sure that we should discuss this here in the public live stream on YouTube, but I'm happy to answer questions about salary in a more personal conversation. What do you do against the sitting all day? The sitting, you mean like sitting on a chair all day? I don't know. I'm not sure how to interpret the question here. Another instruction set architecture, processor architecture question. What do you think of alternative architectures like IBM PowerPC? Did you look into that too? We actually have a PowerPC and looked at that for some experiments. Yeah, I think it's very important that you have an ecosystem where many companies try to improve things, and if everyone tries to improve things, we will get to better processors overall, because otherwise we will run into big problems in the near future with our computers. Thank you for the compliments. It's always nice to hear. RPG Maker, this was taught me a lot about programming when I was little. Yes, I think this was the name of the software that I used as well, but I didn't program or script too much in that. So I didn't really learn programming. So the real programming, learning to program, that was at university. I learned in the first semester to program with pointers, understood pointers. As we're already talking about processor architectures, do you think RISC-V will become a major player in the future? Definitely. Yes, maybe later today, I guess. Do we need 1.0 grades to make a PhD? No. For a PhD, I would say, so I didn't have a 1.0 grade, and also some of my PhD students didn't have that. There are other criteria that are very, very important, and that is, being able to figure out hard problems on your own, solutions to hard problems, basically trying out things, being fast at trying out things, not feeling uncomfortable when trying out new things, like, oh no, now I have to do experiments again. This would be a sign that you would feel uncomfortable while doing a PhD. Being very comfortable with writing. So during your bachelor thesis and your master's thesis, you will write a lot. Doing a PhD, especially in a fast field like IT security, means basically, so for a master thesis, that would be something like 60 pages, a 60-page document that you write, and you will have half a year to write that. Doing a PhD basically means that you would produce the same amount of text and the same amount of result every 3 months. That can be stressful. So if you, during your master's, decide, oh, actually this writing part was fun and also the experiments part was fun, then this would be a sign that you should talk to a potential PhD supervisor. And that can be very independent of the grade, the grades that you have. Of course, for the master thesis, so the writing also has to be good. So you need a good quality of writing, but this is something that your supervisor will tell you. And also, this is what the bachelor thesis and master thesis is for. You will go through multiple revisions of text, and the supervisor will help you improving your writing. So yeah. For a PhD, what you also need is, you need to be fast at trying out things, because you will have to try out a lot of things. Let's say 99% of the things that we try don't work. That means that you have to try out more and more things, continue to try out things. It's like taking participating in a lottery, and only one bill in 100 wins. And the solution there is, if you take more bills, if you take more tickets, then you have a higher chance of winning. And that's how research basically works. So if you are faster at running experiments, and that is probably also the sad part that you will see in many situations, that people will compensate this with investing more time. This is not good, especially it's not good if you don't feel comfortable with that, because this will be bad for your mental health, and I can definitely not recommend that. So what you definitely want to do is you want to only work as much as you feel comfortable and feel happy to work. Of course, if you're a PhD student at an institute, you will probably get a salary, and there will be some hours defined that you have to work. In most cases, it will be 40 hours that you should work. But you will see students that work more than 40 hours, but you will also see people that work less than 40 hours, because the results matter. And as said, some people try to compensate being not as fast as others with experiments by investing more time. And if you do this over a longer time, this will not be healthy, and I cannot recommend that. Okay, let's go for the next question. So yeah, if you know you're fast with experiments and you feel very happy and comfortable with running a lot of experiments that don't work most of the time, then I would consider it. After the bachelor studies, would you say the students are capable to make programming projects by themselves? Sure, I would say yes. So PhD is real research. Yes, a master thesis at our institute is already real research. So you will, if you look through the papers on my website, you will find that about half of them have either a bachelor student or a master student as a co-author. They are doing real research. The PhD students, they do that as their main job. This is the main job they have, doing real research. And you will find that on the papers on my website. For almost all of them, a PhD student or a person who was a PhD student at that time is the first author. That means the person that did the most writing, the most experiments, the most work on this project. So this is why the person is then the first author. And this is what the PhD students do. No question, just wanted to thank you for the lecture. Thank you. It's always good to get positive feedback. Also, if you have negative feedback, if you think some things went wrong, and I've already heard a few comments today, and I'm fully aware of that. The design discussions, the A3 discussion rounds have been criticized in the past as well. We just haven't found a better format yet, and the format of moving them online has definitely not improved the situation. But again, we think that the discussion there is a very important element, that you see the different views, the different observations that different students made, and this is an important part to understand this complex topic of memory observations. Would you consider a FH, Fachhochschule, so it's like a applied university, as serious regarding computer science? Totally depends. Totally depends. Same as it depends on the university with respect to computer science, depends on the applied university. I have seen students that participated, that took the masters in computer science in Graz, that previously were at FH Hagenberg, and they were in some cases even among the top 1% of the students that we've seen in these semesters. So there are really, really good students coming out of Fachhochschulen as well. So it totally depends on the Fachhochschule, and it depends on the student. So whether I consider them as serious or not, we can see that there are students who do just as well or even better than most of the students from our own university. Of course, I don't know about the average, but I don't think that we see the average FH students later on in the masters. I don't know. I couldn't judge, couldn't answer this question. The person who asked about the sitting problem probably meant about home office. Yeah, home office. Yeah. This is also why I created this this initiative to have game nights or socializing events in the Discord, because people might not be too happy with the situation of being stuck home alone, possibly, or always stuck with the same people. So creating this possibility to go out virtually is something that I think is really important. How about doing the discussion rounds as 3 minutes one-on-one with a tutor per person? Within 3 minutes, you won't discuss through the 30 questions. So this is one point. So you won't be able to get all the and also you won't get all the interesting perspectives from the other students. And even with 3 minutes one-on-one, that would be 90 minutes per. I don't think it would have the same effect here. It would feel more like an Abgabegespräch or an exam. When and why did you move to Austria? Because you're speaking like a German dude. Yeah, I'm from Cologne in Germany originally, and I moved here 2008 when I started studying. But the reason why I moved here was not because I was planning on going here for studying, but because my, at that point, girlfriend was from Austria, now wife. Favorite Linux distribution? I'm using Xubuntu with XFCE, but I don't think this is I mean, there are many different tastes, and everyone should pick the Linux distribution that they like the most. So, yeah. How important are grades for the industry in your opinion? Do they matter at all if you apply to jobs? It depends. It totally depends on your situation. If you apply for jobs right after the bachelor's or the master's, yes, they do. Depending on the topic, depending on the area, they will even look at specific grades. So we've heard from companies in and around Graz that ask specifically for the grade in operating systems. Also from some companies abroad that ask specifically for the grade in operating systems. And yeah, then of course it matters, yeah. Do they matter if you apply to jobs? If you do a PhD, things will change. With a PhD, people will look at your CV and will take a look at how many papers have you published, where have you published the papers. So the grades don't matter there anymore, but it matters, have you published a significant number of works and significant works in itself. Live programming to teach theory topic is awesome, but could you prepare those better? I could remember we needed like 2 weeks lecture time to get that program working. You live prog around E2 time. Yes, I also remember that. I actually prepared that, so I had the solution. I implemented the solution right before the lecture, and I still don't know what I got wrong in the lecture itself. But things like that can happen if you do the live programming. So I wrote the same thing right before the lecture, wrote it again, and somewhere took the wrong turn. I think I introduced an increment with very deep within the loop, and this inherently produced a race condition that I wouldn't be able to solve without moving this increment further to the outside. And this was a very, to me, subtle mistake that I didn't see immediately, and this cost us a lot of time. But this is, if you program things live, then things like that can unfortunately happen. Which music genre is your favorite? My girlfriend wants to know for some reason. Oof, music is, I think music is very, very personal, and this, music is very personal. I don't know. We can discuss this over a beer at some point. Where's the cat? Let's see. We can see whether she comes here. Look what we have here. Isn't this good? Okay. And one step further, one step further. Come over here, and here you have your treat. Very nice, very nice. Oh, yes. Here we have you. Okay. Let's continue with the next. Oh, you're stuck, right? Okay, but you won't be able to see her now. Okay, I use Arch, by the way. Yes, congrats. Do you like the concept of snaps from Ubuntu? I like the concept, but oh no, now she's typing. Yeah. I like the concept, but I sometimes feel they are very, the keyboard is very comfortable. They are sometimes very bloated, but I think that's inherent to the concept. I like the concept, but you have no interest in industry job. I applied for some industry jobs, but they all said I wouldn't be able to teach classes if I take the industry job. So it was not really an option for me. I want to continue teaching classes. Favorite famous computer scientist. Favorite famous computer scientist. The question is, what would you? Who comes to your mind first? There's definitely so if you're talking about famous and old, like this scale of let's say Grace Hopper, Alan Turing. They are famous, but if you think about people that are still alive, then probably the famous that I think about, you might not know these names, which would be people from my community. Laptop, I won't recommend laptops. That's not my profession. How exactly does Platypus work, and how did you discover it? We've been working on, so generally power side channel tags are a very old topic. This exists since the late 90s, and our institute has been working on this since the late 90s. That we can do this from software was an idea that first came up between Stefan Mangard, Moritz Lipp, Michael Schwarz, and me in 2017, or even earlier than that. We thought about the possibility of that, and we started working on that, but it was difficult to get a resolution that was high enough. And last year we had some breakthrough there and were able to get a higher resolution. A lot of work there was done by Moritz Lipp. Most of the work was done by Moritz Lipp. And also Andreas Kogler invested a lot of time there. So we discovered, so basically it's not a significantly new discovery that you can do. So if you look at the single components, software-based power side channels existed before, but they were not able to leak anything interesting. Power side channels that leaked interesting things like cryptographic keys existed before, but not in software. So the thing that we did here was combining those things and doing a lot of work to get this to run properly. And the joint result there is then the interesting part. So how did you discover it? It was not really unexpected that this would be possible at some point. It was just a lot of work to get there. Yeah, okay. She probably likes your keyboard if it is heated in any way. I'm not sure that it's heated, but I think she wants to sit there because the cat treats are right next to it. Wenn man exmatrikuliert wird wegen 3-mal Plagiaten, darf man dann. So if you're unsubscribed from the studying program because of plagiarism, then you cannot study the same studies anymore in all of Austria. I don't know. Actually, I don't know. I don't even want to know because I never want to get anywhere close to that situation. I don't think any student should get anywhere near this situation. Are you considering to get financially free? I don't know what you're meaning here. Your lectures are amazing. Thanks for all the effort you put in them. Thank you. If I make some mistake in some field during studies, which is important to me, let me see anyways. I really worry about it for a long time and I always think it's a really stupid mistake. If you make a mistake, I think learning is a lot about making mistakes. Actually, I think this is my most favorite way of learning, trial and error. So really making a lot of mistakes for me works the best, because if I make a mistake and realize what the mistake was and how it actually works, I memorize things way better because I sort of figured out myself or figured out for myself what the mistake was. And so this sort of is now my own created knowledge. By solving my own mistake, I created my own knowledge, and what I created myself, the knowledge that I created myself, I won't forget that easily. Do you think years ago it was easier to get a bachelor in computer science? When I see that some professors at TUG have a degree title, I can't believe it. The professors are not necessarily, as far as I know, many of the professors from TU Graz are not from TU Graz, and they might be from other universities. And also the question is, what is the focus of these professors? If you think about a professor who is there at university for 20 years, the main tasks of these professors, or of any professor, is to manage a large team of researchers. Speaking of something like 6 to 20 PhD students that all need supervision with their research experiments, with the direction, with the writing, that need a lot of help. And for these, even if you can only allocate maybe 1 hour, maybe 2 hours per week per student, this is already a large part of your time. The rest you will work a bit on teaching, so teaching consumes some time, and also you have to make sure that the finances of your group are fine, that you get enough money in so that you can pay your PhD students a salary. So you you won't necessarily practice and train the skills anymore that you were practicing and training as a bachelor or master student in computer science, because your job just changes. It's a different job. You have to do different things and get better at these different things that are managing and maintaining the finances for your group. And hopefully also teaching, but teaching, there are currently no incentives or no significant incentives for professors to improve their teaching. And you present something at 37C3. I'm not sure whether I missed the CFP there, but I haven't seen anything yet whether there is a CFP. We would like to present something there, so my group would like to present something there, but so far we searched for a call for presentations, but we didn't find anything. And because it's virtual, we don't know whether and how this would be announced. So if you have any information, please let me know. Yeah, someone in the chat writes, admitted it's death metal. No, I really don't like death metal. It's far from death metal. How do I actually know if I'm interested in computer science at all? How do you know if you're interested in computer science? Good question. I was always interested in computers and how computers work. So this is the perspective that where you need to give me a moment to think about. So I would say if you have fun while working on computer science problems like exercises, if that's fun for you, if you can program something and feel like, yeah, that was fun, if you achieve something and say that was fun, then I would say that's a good sign. If you are like always saying like, I don't even want to do this, then maybe you're not interested. But it's difficult for me to tell. But if you want to, we can, at one of the next social events, we can have a chat over some drinks and elaborate on that question. If you do a PhD, do you automatically become a professor if you stay at university? No, and that's not how it works. Usually we have a lot of bachelor students, and then we have a few master, so a lot fewer master students, maybe half as many, maybe 2/3. It depends a bit on the studying program. So fewer master students, and then out of these, very few start a PhD. And out of the PhDs, very, very few continue with an academic career, and then it continues as a postdoctoral researcher. And maybe out of the PhDs, maybe off the top of my head, I would suspect that maybe 10% maybe continue as a postdoctoral researcher in academia. And then out of all the PhDs, maybe 1% becomes a professor. Something like that. Maybe I'm off by a bit, but this is off the top of my head the numbers that I think that we have. But you can look up the statistics. There are public statistics about that. How many PhD students you have, and how many professors, how many become professors later on. So this is really like a pyramid, and only very few people can become a professor. The problem I have as a student is that I'm often overwhelmed by the things I know I cannot do yet. This is something that in research you will also find. So even today we are often confronted with problems that we need to solve and we don't know how. And this can be frustrating. And how do we solve that? By practicing these situations. We practice being confronted by difficult problems, and the more often we practice this, the easier it becomes. Could we have a bonus lecture in which Hexe does some live programming? I don't think it would compile. And with that, we are through the Q&A. Thank you for still staying here, and I will switch to Discord in a second so that we can directly continue with the question hour there. Thanks for being here, and see you in maybe the exam if we have one, and otherwise next semester in the operating systems lecture. Bye.